Okay, let's learn a little bit more about inscribed angles. So these are our content standards and mathematical practices for the assignment we'll be doing today. So previously you found measures of interior angles of polygons, and now we're going to find measures of inscribed angles and find measures of angles of inscribed polygons. New vocabulary: inscribed angle, an intercepted arc. An inscribed angle has a vertex on a circle and sides that contain chords of the circle. So in this circle, angle 1 is an inscribed angle. An intercepted arc has endpoints on the sides of an inscribed angle and lies in the interior of the inscribed angle. In this circle, minor arc AB is intercepted by angle 1. So let's use inscribed angles to find measures. To find the measurement of angle X, we know that the inscribed angle is half of the measure of the intercepted arc. So half of 86 would be 43. So the measurement of angle X is 43. Let's find the measurement of the arc YX. Again, we know that the inscribed angle is half of the measure of the intercepted arc. So 2 times the measurement of that angle would give us 104 as a measurement of the arc. So let's check your progress. So pause the video for a moment and then come back and check your answer. Very good. We know that the measurement of angle C is half of 94. How about finding the measurement of arc BC? So pause the video and come back and check your answer. Very good. We know that the measurement of this arc is twice the measurement of that inscribed angle. Excellent. 2 inscribed angles that intercept the same arc of a circle are related. This theorem tells us if 2 inscribed angles of a circle intercept the same arc or congruent arcs, then the angles are congruent. So let's use inscribed angles to find measures. Okay, so angle R, we're to find the measurement of angle R, and angle R and angle S both intercept arc TQ, so that means that they are congruent. Definition of congruent angles. So we can set these two quantities equal to each other, solve for X. Now we need to go back and substitute. We've got to find out what R is. So we substitute 5 in place of X. 12 times 5 minus 13 is 47. Okay, so check your progress. So pause the video and then come back in a moment to check your answer. Okay, so we see that both of these inscribed angles intercept the same arc. So they're equal to each other. So we can set 8x plus 9 equal to 10x minus 1. X is 5. We need to find the measurement of I, angle I. So 8 times 5 plus 9 is 49. Very good. Now we get to use inscribed angles in proof. We're to write a 2-column proof. We're given that arc LO is congruent to arc MN. Okay, LO is congruent to MN. And we're to prove that triangle MNP is congruent to triangle LOP. So first of all, we're given the 2 arcs are congruent. So if minor arcs are congruent, then the corresponding chords are congruent. Now, definition of intercepted arc. Both angle M intersects NO, or arc NO, and L intercepts arc NO. Inscribed angles of the same arc are congruent. So angle M is congruent to angle L. And angle MNP is congruent to angle OPL because vertical angles are congruent. So you need to check to see, what do we have? Angle, angle, side. These 2 triangles are congruent by angle, angle, side congruence theorem. Very good. Okay, we're to check our progress and we're to write a 2-column proof as well. So it's going to be several screens, so you might pause the video and draw a picture sketch this in your notes and what's given and what you're trying to prove. And let's get started. So we're given arc AB is congruent to arc CD. We're given that segment AB is congruent to segment DC, because if minor arcs are congruent, then corresponding chords are congruent. Definition of intercepted arc. Both these intercept the same arc, so that means they are congruent to each other. Inscribed angles of the same arc are congruent. Vertical angles are congruent. So now give me the reason of what completes why we can say these two triangles are congruent. Is it A, B, C, or D? If you said angle side congruence theorem, excellent. Awesome. Triangles and quadrilaterals that are inscribed in circles have special properties. So this theorem tells us that an inscribed angle of a triangle intercepts a diameter or semicircle if and only if the angle is a right triangle. So if it intercepts the diameter, you know you've got a right triangle. So find angle measures in inscribed triangles. Well, as we see, this one goes through the diameter. Angle C inscribes a semicircle. So by the angle sum theorem, we can say that all three of these are equal to 80, and we know that C is a right angle because it goes through the diameter. Solve for X. Now we substitute back in. 8 times 10 minus 4 is 76. Okay, let's try one on our own. So pause the video, then come back and check your answer. As we see, angle F inscribes a semicircle, so we've got F as a right angle, so we can say 2x plus 6 plus 8x plus 4 plus 90 is equal to 180. So x is equal to 8. We're asked to find the measure of D. 2 times 8 plus 6 is 22. While many different types of triangles, including right triangles, can be inscribed in a circle, only certain quadrilaterals can be inscribed in a circle. Theorem 10.9 tells us if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. Okay, so let's look at insignias. An insignia is an emblem that signifies rank, achievement, membership, and so on. The insignia shown is a quadrilateral. Yes, it is four-sided, and it's inscribed in a circle. We're to find the measurement of S and the measurement of T. Now, since TSUV is inscribed in a circle, we know that opposite angles are supplementary. So since these two opposite angles, one's 90, we know that the measure of angle 6 is 90, and we can set these two equal to 180 and solve for X. So the measurement of angle S is 90, and for the measurement of angle T, we can do 8 times 8 plus 4 is 68. Okay, time for you to check your progress. So here we have another insignia, and you pause the video and then come back and check your answer. Okay, I set up 11x plus 3x plus 12 is equal to 180. So x is equal to 12. When I substitute it back in, 3 times 12 plus 12 is 48. Very good. You're ready to begin the assignment today.